Determination of total hardness of water using disodium salt of EDTA. To do this experiment, first step will be the preparation of standard solution. And to prepare the standard solution, the salt we are using is disodium salt of EDTA. Accurately measured disodium salt of EDTA is to be transferred to a clean standard flask using a funnel. Now, half a test tube of ammonium hydroxide is to be added. Then we shall add some quantity of distilled water to it. Then let us shake the standard flask well so that the salt gets dissolved completely. When the salt gets dissolved completely, we shall add more quantity of distilled water to it. And you make it up to the mark using the distilled water. And you shake it well to get uniform concentration. Then we shall rinse the bread and you fill it up to the mark using the standard solution of disodium salt of EDTA. And to do the estimation step, 25 ml of the sample solution hard water is to be pipetted into a clean conical flask. To this, about 5 ml of ammonium chloride buffer solution is to be added. And now let us add 3 to 4 drops of the indicator Aerochrome black tea. Now the color of the solution will change to wine red. Now we shall start to do the titration against standard EDTA solution till the color of the solution changes to clear blue. This is our end point. Wine red color should change us to clear blue. Now we shall note down the volume of the EDTA solution consumed. And in order to get the concordant value, 2 more trials are to be performed. After the completion of all the 3 trials, we shall do the calculation. And to do the calculation, so here it is the weight of the weighing bottle along with the salt. Then we are going to call that as the W1. Then weight of the empty weighing bottle, so that is W2. And if you take the difference between the two, we will get the weight of the salt. In order to calculate the molarity of EDTA, weight of the salt W is to be divided by the molecular weight of EDTA. And the molecular weight of EDTA is 372.24. And that ratio is to be multiplied by 10. So then we will get the molarity of EDTA and we are calling that as A. And the titer value will give us the value V. Both the A and the V values are to be substituted in the formula to get the weight of the calcium carbonate present. A is the molarity of EDTA, V is our titer value, then 100 is the molecular weight of the calcium carbonate, and that is to be divided by 1000 to get the weight of the calcium carbonate. And in order to express that in terms of parts per million, that is to be multiplied by 10 to the power of 6. Then we will get the total hardness of water and we shall express that in terms of parts per million of calcium carbonate.